Hello everyone, thank you for joining us for the second webinar in Simba's Big Data webinar series. My name is Hanne-Sophie Solhaug and I am with the Simba's marketing team. We're almost ready to get started. We'll just wait one more minute for the final few to join us. I can tell you a little bit about who we are while we're waiting. As you know, we're Simba Technologies, the data access and analytics experts. We co-developed ODBC with Microsoft back in '92, and this year marks ODBC's 20th anniversary. The world's first ODBC driver, Simba.dll, was included in Windows 3.1, and that's how standards-based data access was born. Simba introduced the world's first ODBC software development kit in '93, Simba Engine SDK, which has been the staple ODBC toolkit used by ISVs worldwide ever since. The SDK can be used to create custom ODBC, JDBC, OLEDB, and ADO.NET connectivity. So we're really excited to celebrate 20 years with ODBC this year. Today, Simba's data access and analytics products span both relational and multidimensional technologies. We have a really exciting webinar planned for you, and I think we're just about ready to get started. Okay, it seems like everyone has joined now, so let's just get started. Thanks again for joining us, and welcome to the second webinar in Simba's Big Data webinar series. As mentioned, my name is Hanne-Sophie Solhaug, and with me today I have Kathy Dumas, Simba's Director of Program Management Analytics, and George Chow, Simba's CTO. Feel free to submit any questions you might have at any time, and we'll try to address them all towards the end. We have a really great demo for you today where you'll see the full SQL application capabilities Simba's Hive ODBC Driver provides. But first, Kathy will start by giving you a brief overview of Hadoop and Hive.
Thanks, Hannah. Let me just walk you through very quickly a 10,000-foot overview of Hive and Hadoop. So here's a little architecture diagram that shows how Hive clients can connect to Hive services and go to the back end against a Hadoop cluster. So as you may be aware, your data lives in the Hadoop cluster here in the back end. And the various distributions package a bunch of Hive services together that allow you to query the cluster and do some analysis and get some useful data out of them. A lot of people are familiar with the command line interface that's provided by Hive that goes against Hadoop. And you'll use this command line interface for a whole bunch of things, right? You can go and you can interactively query using HiveQL at the command line. We use this command line interface ourselves to load up the data set for the data that we're showing you today. So to get the data for our FAA data set, which I'll show you later, we went to the website. We got a bunch of data in a text file in a CSV file format, and then we issued a bunch of commands of this Hive command line to upload the data to our Hadoop cluster so we can query it. So the command line is a powerful tool, but it's not all that's involved in some of these Hive distributions. The part that's really important that I want to point out to you is the Hive server. Not everybody knows that you can have a Hive service that listens for requests and takes application requests from outside of Hive and translates them and sends them to the Hadoop cluster and sends back results. So one of the most critical things that people need to know and that you need to know if you're going to get the Hive ODBC driver and use an ODBC application is that you must have the Hive server up and running in your environment before the application can do ODBC queries. And then what happens is once you've staged your data and started your Hive service, your ODBC application simply connects to the data by using Simba's Hive ODBC driver, which then goes and talks to the Hive server. And then the Hive distribution takes care of the rest, spits it out to the data source, comes back, gets the results, and then you see the results back in your application. So this is at 10,000 foot level how the Hive architecture works with Hadoop. Okay, so if you have questions on that, be sure to send them in, and we'll try to address them by the end of the webinar. But that's enough slides. Let's take a look at the demo from Tableau, and we can see what this looks like. So I've got my Tableau client up and running here. The first thing that I do to connect to my Hive data source is to use this data connection pane here. And Tableau's made it really easy to pick out the data source that you'd like to use. Today we're going to be using the MapR distribution. Simba implemented MapR's driver, which is plugged into Tableau, and George will explain the details of that a little bit later, the relationship between the two. But once I've picked MapR Hadoop Drive, Hive, all I have to do is put the IP address of my server, connect, get my data set. Remember how I told you I had that FAA data set? Oops. Now I can pick a table from this data set, so select. Before I click OK, just remember that this is big data. I have a tiny little laptop here. I don't want to pull down all of the data from my table, so let's just change the HiveQL here. Let's just get the top 1,000 rows. Now what happens when I click OK is Tableau issues a metadata discovery request. So Tableau's columns are pretty smart. You know, it infers certain things based on the structure of the column. So it knows if it's a latitude or a longitude or a city or a state or a number or whatever. So it has to issue this metadata query, get the types of the columns, and then it gives you this choice once it's figured out the metadata. You can connect live, which means every query goes against your server, or you can import the data into Tableau and get all the data down in a single query, one shot, and then just interact with Tableau's internal engine when you're playing with the data in Tableau. So I'm going to take this option because whenever you're dealing with big data, what happens is the queries can take a long time to process on the back end for Hadoop. And, you know, that's the nature of the architecture with the MapReduce jobs. So you want to make sure that you pay that cost up front, let the back end do the heavy lifting and the aggregation, pay that cost once, and then be able to work quickly. The other advantage of these extracts that I'm using is that you can share them between users so that I'm the only person that has to pay this tax of importing the rows. I could share this with Hannah and George and they wouldn't have to wait at all. They'd see what you see right here. And here's all my dimensions. So like I said, when it did the metadata discovery, it figured out that things are cities and numbers, and I could just explore what I have in this data set here. So I've got destinations, you know, origins, flight numbers, flight names, and I've got some information about these. So arrival delays, how long they were in the air for, was the flight canceled, that kind of stuff. So let's use some of Tableau's snazzy visualizations to take a look at this. So I can look at, for various flight routes, say I wanted to look at arrival and departure delays for various routes here in this grid. Okay, I can visualize these pretty quickly. So it's just drag and drop. Let's do departure delays first. Maybe arrival delays. And by default, it aggregates by sum, but I can always change this aggregation to average. And if I wanted to see just tables, I could do that anywhere, like in Excel. This little show me thing shows you all the different visualizations you can use. And one thing that's special about Tableau is this thing called a heat map. And the heat map just gives you a size-based visualization, and if we make it a little bit bigger, you can see the size better. That allows you to look and see where you tend to get the longest delays. And we can see that they're in Hawaii. And Hawaii is the kind of destination where it's worth the wait. So I guess if you're flying to Hawaii, just be patient and you'll get to the beach eventually. You can use multiple measures here as well. So if I wanted to look and see how the delays stacked up against, for departures, stacked up against the arrivals, I could just put the departure delays here, and I can see if I'm flying from O'Hare to Hawaii, I'd better hold my horses on both ends because I'm going to be waiting quite some time. And Tableau has this thing, by the way, it automatically infers the colors and it thinks that bigger is better. In this case, it happens to be wrong. I think delays are bad. So yeah, you can see that this is one of the most congested cities. So that's cool. But let's look at some of the other things that Tableau has to offer. For example, Geospatial. Now you can see here that it had automatically tagged from my data source that these were geospatial entities, the destination and city names, but it doesn't actually know what the locations are. You know, I can go through, because it has a geographic role, I could go through and map this for every single origin and destination, but that's kind of tedious. I don't want to do this. So what I did was I created a new data extract so that I could do that kind of analysis. And I did some aggregation on the back end, and I added more rows to do it. So let's take a look at this example. So here's my Tableau data extract. Don't worry, I'm going to show you the query that I used to generate this a little bit later. But right now, let's skip to the results. So here's my origin and destination, and you can see here I actually brought in the latitude and longitude, which wasn't in my other data set. I got this from a join. Very cool. And I've got this path order thing. It's very strange, but let's do it. So latitude, longitude. And when you do that, it determines that you want a map, which is very smart. I did want a map. Good. So I want to visualize, let's visualize the routes, and we'll look at the delays by the various routes. So when I brought this in, I created a little, a field here that shows which two airports it's flying between. And let's draw it some lines so we can see the lines between the airport. Whoa. And I can show you a little trick. The way to make sure that Tableau draws the lines in the right order is to use this path shelf here and to have this path order variable to make sure it draws the lines between the origin and the destination correctly. So you can see there's a lot of flights in the United States, and it's kind of hard to read here. So let's do some filtering. So what I can do is I can filter by origin, drag and drop here. And if I turn this into a quick filter, see down here I can pick which origin I want to take a look at. So say JFK. Now that's making a little bit more sense. Now I can see all the flights coming from JFK. And if I want to take a look at the delays going out of JFK, what I can do here is I can analyze by color, like I did on my heat map. And it has that same problem where it thinks long delays are good. So let's make them bad. Alright. Good. So the darkest red color you can see are some of the longest delays. But because there's a lot of flights here, it's hard to really get an idea of what the top 10 are. So we can do a little bit more filtering to figure out what the top 10 longest delays are. So I add this filter to my context. That's a Tableau trick to make sure all the filters work together. And then I can just get my top 10 delays. And this summarizes the information for me. So I can see that if I'm flying between Dallas, Fort Worth, and O'Hare, because these are the darkest colors, those are the longest delays. Which is a shame because those are the hubs, and that means by connecting flights I might be delayed and I might miss my connecting flight. But at least now that I've been working with Tableau, I have this kind of insight so I can be prepared when I get to the airport. So, one last thing before I turn this over to George. I promised I would show you the query that I used to generate this. And again, this is HiveQL, so don't worry about the squiggles. It's just my editor doesn't understand HiveQL, but I do. So, I don't expect you to wrap your head around all 48 lines of this query. But I just wanted to put this up here to give you an idea of the expressiveness of HiveQL and the kinds of complex structures that you can build up here. Okay, so for example, remember when I said that that city-state combination in the name didn't work out for Tableau's Geospatial? You could use built-in functions like substring just to get the city name out, right? I just chopped off the state at the end, you know. I use the average function here so that it does the average aggregation at the back end at the initial query time instead of at the front end when I query it, right? I got concatenations to make my pretty little root thing. I've got this path order here, and this is another Tableau-ism. This is how I formatted the data so it could draw the lines between the origin and the destination. That's what this path order and this union is all about. It's just making Tableau happy so that it understands that I have an origin airport at path 1 and a destination airport at path 2. And then it has rows for each of those, so it knows how to draw the lines. So I can just, you know, use constants to add these values and then union the sets together. And to get the latitude and longitude, I joined together my flight data table with my airport latitudes table. So I had just imported those two tables at two separate times in a Hive. And I can use joins just like in SQL, so I got my left outer join going on here, to join those two tables together so that I could use them in one view for analysis in Tableau. You know, and I got grouping here so that my averages work. So this just gives you an idea of the sorts of things that you can express in HiveQL. It's pretty much everything you could do in the SQL language, and you can even throw it all into one query. And then it shows up in Tableau. So that's the demo, and now I'm going to hand it over to George, and he's going to talk through some of the technical details of our implementation.
Thank you, Kathy, for that demo. So I'm George Chow, CTO of Simba. So thank you again for joining us in this second session. So let me get into the internals of the ODBC driver. We built our driver with two goals in mind: coverage and ubiquity. So what do I mean by that? So if I look into it, by coverage, what we're referring to is where the data is residing. Our driver supports Hive data that resides in any distribution or the ecosystem. So whether you're living on DataStax or Hortonworks or Mapr or beyond, these are just some of our current customers. But let me elaborate on what we did for Mapr, since you saw the demo earlier on for Mapr. Mapr provides an enterprise-grade Hadoop distribution. So their M5 release adds a lot of important critical features such as high availability and HFS mountable file system on top of the Apache release. So their distribution also includes Hive. And when Mapr was looking for advanced connectivity to Tableau, they reached out to us for their technology. And what we did was that we provided a driver for them that was tailored to Mapr's need. The driver connects optimally with Tableau and is also branded as an Mapr component. I'll dive into some of that a little further on. But to finish off, by ubiquity, what I'm referring to is where and how you can use the driver. You've already seen in the last demo, the first in our series with Excel, and now you've also seen just now with Kathy's demo of Tableau that we focused on making the driver compatible with all your apps. So whether you're looking for something on the desktop, such as Excel or Tableau, or if you're looking for something that is maybe a little more enterprise scale, such as Crystal or MicroStrategy, we've worked out and tuned the driver to work optimally for these. So let me dive some more into the ODBC driver. Our ODBC driver is built using our proven Simba Engine SDK. So this is the same technology that's used by the likes of Teradata and Vertica and other leading vendors. We support the industry-leading ODBC 3.5 API for highest performance and compatibility. And we also support this, of course, across a wide selection of platforms, starting from Windows and OS X on the desktop through to the various enterprise-grade Unixes and Linuxes. But let's look inside the driver some more. On the top here, inside the box, you'll see that we have a high-performance ODBC interface. And on the bottom edge, you can see that there's a driver implementation that we've developed for Hadoop and Hive. So these two components together gives you native HiveQL processing capability that's comparable to what's available with the other drivers on the market. But what's really exciting and what's different about our driver is actually the SQL connector. The SQL connector is a feature within our driver that gives us full standards compliant SQL 92 processing capability. And we can do this, of course, because our Simba Engine SDK includes a full SQL engine and parser. If you were with us in our last session, you'll recall that Excel uses our SQL connector feature to translate standard SQL that Excel generates into HiveQL. And with Tableau, we didn't need to use this because Tableau is Hive aware and generates HiveQL directly. So what does all this mean? With our Hive ODBC driver, you get the best of both worlds. If you're using an app that is SQL only, you get to use our SQL connector, which gives you fullest SQL 92 compatibility. You get the full capability of the language, and you have maximal app compatibility. If you're using instead a Hive aware app, of course you get the rich capability of HiveQL, and you'll get the highest performance backed by an industrial strength driver. So to close off, it comes down to coverage and ubiquity. Our Hive ODBC driver covers all the Hive sources for you and gives you the full compatibility across the widest selection of applications. So to conclude, I'll hand it over to Hannah to wrap it up.
Thank you for that, Kathy and George. That was really great. So this ODBC and SQL solution for Hive is already used by industry innovators such as DataStax, MapR, and others. And it connects any SQL-based application to any Hadoop Hive distribution. And it is available now. The Simba Hive ODBC driver with the SQL connector is only one driver within Simba's Big Data suite. We also have similar drivers for Cassandra, MongoDB, BigQuery, and others. We will demo some of our drivers at Strata New York and Hadoop World. That will be at the Hilton NYC on October 23rd to the 25th. So make sure that you come by our booth, booth 1A, for a chat or to watch our demos if you'll be at the conference. So we still have a few minutes left, and we'll now open up for questions. It looks like we have a few questions already, so I'll just get started. First question for the day: how does Tableau recognize the Simba driver? George?
Thank you, Hannah. The Tableau recognizes a driver based upon customized branded drivers. Or put another way, we provide an OEM kit that allows you to brand the driver as your own, and in turn, Tableau recognizes the specific branded driver itself. So if you're interested in using the driver, you will take the OEM kit, you will brand the driver as your own, and then we can work with you then together with Tableau to ensure that you get built into Tableau as a first-class data source.
Okay, thank you, George. Let's see, next question here. Okay, how can I share a Tableau visualization?
This is, of course, a Tableau question, really. But if you look at Tableau, we demoed what we call the Tableau desktop, which is the desktop or the authoring side of the Tableau suite. Tableau also includes a server component, which allows you to publish and to share any of your visualization online. So, and if you're interested, Tableau also includes a Tableau public version of the product, which is freely available for you to actually share and visualize smaller data sets. So you should go take a look at tableau.com to find out the full selection of products and capabilities.
Okay, and then someone here is wondering when the driver is shipping.
The driver has actually been shipping since, I think, July it is. So, it's available immediately. So if you're interested, by all means, come on by, drop us a note, and we'll get you started ASAP. But it has been shipping through since June, and all our customers are in various states of availability. So I think, if I recall, MapR is already online, and DataStax and Horton's are just around the corner. Anno might be already up by the time you are seeing this.
Okay, we have time for one more question. Someone is asking, what about HCatalog?
Oh, that's a good question, Hannah. HCatalog. Okay, for those who don't know, HCatalog is I would say it's an evolution of Hive that is still in progress. So for those who don't know, HCatalog is essentially is a feature within the next release of Hive, which will be sharing metadata across different big data products. So today, if you have data residing in HDFS and if you stand it up inside Hive, if you saw earlier when I was with the create statements, that metadata that you set up inside Hive would need to be redone when you load the data into HBase. And with HCat, that will no longer be necessary. In essence, HCat is a shared metadata repository that will be used by all the by the next version of all the various Apache Hadoop family of products. So you can expect that once you load data into HDFS, you'll be accessible. And to answer the question, then Simba is, of course, carrying this driver forward. It is a significant. It's a cornerstone product of our suite, and so we will be evolving the product and building in new features such as HCatalog into future releases. So look out for that.
Okay, thank you, George. That's unfortunately all the time we have today. However, if you have submitted a question that we haven't addressed, we'll try to follow up with you directly as soon as possible. Thank you very much for joining us today. Please check out our website at simba.com/hive if you'd like some more information about the Simba ODBC driver with SQL connector. You can also give us a call at 604-633-0008 extension 2 or email us at solutions@simba.com. Stay tuned for more webinars in our Big Data webinar series. We will be publishing new dates very soon. Thank you very much and have a great day.